Alrighty, let's see what I got today. Convert binary number to in a linked list to integer. Alright, given head, which is a reference node in this. Given head, which is a reference node to a singly linked list, the value of each node in the linked list is 0, 1. The linked list holds the binary representation of a number. Okay. Return the decimal value of the number in the linked list. The most significant bit is the headed list. 1, 0, 1 is equivalent to 5. 0 is equivalent to 0. Okay. This seems pretty straightforward. Very similar to how you do it if it was an array rather than a linked list, as long as you know how to go through the values. So let's say answer is initially 0. And so traversing the nodes, it'll be while there is a node that exists. The answer should be equal to 2 times the answer plus the node value, so head.val. I think that's how it goes, and then head becomes equals to the next value, or the next node after it. And then return the answer. Yeah, so a couple of notes would be if the node ever reaches the ending node, it's equivalent to null, and then the while that node condition is, that's going to be false. So that's how you can loop through values, and then to iterate from node to node, you generally will say the node that you're at is assigned to the node that's after it. So the node that's after it is going to be head.next. This is probably better if I said something besides head here, like maybe I said current equals head, and then while current, do everything. So yeah, replace head with current. Just because head itself is probably a poor label for something that's changing and not being a head afterwards. And then for binary stuff, just like for decimal stuff, if you're going through digit by digit from the kind of leftmost digit, which is the highest value digit, to the least value digit, the rightmost digit, the way that you construct the overall value of the number would be you do the base times the current digit plus the base times the current value plus the current digit. So if you had a number that was to say 314, and you're iterating over 314 in terms of constructing a value that's decimal, it'll be like initially you start with 3, or initially you start with like 0 as your overall value, times 10 plus 3, which equals 3. And then you do 3 times 10 plus the 1, and that gives you 31. And then you do 31 times 10 plus the 4, and that gives you 314. So the iteration in the kind of loop iteration process would be take your previous value that you had starting with 0 times the base, which if it's decimal, base value is 10, so 0 times 1, and then whatever your current digit that you're iterating at, so 3, and then that'll be your new stored value. And next time you do it, again, multiply by 10. Anyways, that same process is for binary times 2 rather than times 10. Summary. Binary value construction is base 2. of 10 while iterating over digits from left to right. Most value digit to least value digit. You might need to do, if you're iterating digits from right to left, it would be, if you're iterating digits from right to left, it would be something like you have some increasing place value variable that's increasing by factor 10. That thing times your current digit plus your previous value would be the instruction there instead. Anyway, summary. Go through nodes using while loop, and then use construction algorithm described above to recreate overall value based on digits, or in this case bits, left to right, and then turn can reassign current node to node.next to iterate over nodes. Time complexity is going to be O of n, where n is the number of bits in the node chain, or I guess number of bits slash number of nodes in node chain. We're doing that one per loop. And then space complexity is going to be O of 1 as no extra space is needed. Appropriately wait, did I actually, didn't actually write that appropriately classified as easy, I think.